All right, now let's do a chi-square example. Remember, we have 3 examples in the lesson. 2 of them are for one-way chi-square, 1 is for a two-way chi-square. This is one of the examples of the one-way chi-square. Please know there are hundreds of different types of ways you can do a chi-square, set up the experiment. We're just going to only stick to 2 different ways you can do a one-way chi-square. Here's the first way. The first way is if you have, well, our experiment is on spanking and socioeconomic status. So we have something like SES right here, socioeconomic status, how much money people make. We have 50 people that make less than $20,000 a year. We have 21 to 40K, another 50 that make that much money. We have another 50 that make 41 to 60K, and we have a last group that makes 61K and above. That's another 50. So the one thing about this is we only have one factor. The factor is socioeconomic status, how much money someone makes. And where our dependent variable is going to be is spanking. Were you spanked as a child? Real simple question, yes or no. So this is a nominal dependent variable. It only has 2 options. So what we have is we enter in the real data that'll be given to you. 45 people said that here, 25 said here, 26 said that here, and 24 said that here. Okay? So we look at our chi-square formula. Chi-square formula is very simple. The sum of what's called the f sub o minus the f sub e squared over the f sub e. Let's go over this formula real quick. It's really a simple formula. Quite simply, you have f sub o, which is the frequency that is observed. Well, these are the observed frequencies right here. The observed frequencies have to be given to you in the problem. This is the tricky one. Expected frequency. What's the expected frequency if the null hypothesis is true? Okay? So the null hypothesis being true would mean all these cells are the same. They're equal. There's no difference between them, right? Because null hypothesis is no difference between the groups. But picking a number can be a little tricky. Because you could put 0, 0, 0, 0 in here, and null hypothesis would be true. You could put 50, 50, 50, 50 in here, and null hypothesis would be true. Okay? But specifically, what we want to do in this case, since we have an equal number of subjects in each condition, this isn't very common, but in this example, this has to happen. You have to have an equal number of subjects, and you have to have a 2-point question, yes or no. In that case, we split this number in half, and we make the f sub e 25. 25, 25, 25, 25, all 25s. There'd be no differences between the levels of the independent variable. That's the number that is most rational, that half got spanked, half didn't get spanked. That is the best number to use for the expected frequency. So what we're going to do here, whenever we see this big sum, you want to have one of these things for every cell you have. So the first thing I would do is do that. You got the f sub over the first one, minus 25, plus, because we're summing them all together, the f sub o of the second one, 25, plus the f sub o of the third one, 26, plus the last one, f sub o, 24 minus 25 squared over 25. That's the way you set up this experiment. Okay? If you do the math on this, follow through, you find out the x squared equals 16.08. And that's what we want to do. That's our chi-square for this formula. We then go over to the significance table to see if it's significant or not. Okay? So, in this particular one-way chi-square example, where you have an equal number of cells, and you have this dichotomous dependent variable, yes, no answer, you split that number sample in half. That's your f sub e. Plug the values into the formula, solve for the equation.